Okay. Yeah, good morning, everyone. So, yesterday we started with our sets chapter. I think it's easy for everyone. So, we will be moving towards some deep concepts of Venn diagram. Okay. So, first we will get a quick revision of yesterday's class. So, we represented sets in a box. In a box. This box is known as universe. This box was known as universe. Okay. So we represented set in this box. This was known as universe. If two sets were there, one set was set A, one set was set B. Okay. So if two sets were there, A and B, correct? So we said this region will be known as only A. This region will be known as only B, or this can be written as A minus B, or this can be written as B minus A. Okay, this region will be known as A intersection B. Yeah, Kritika, I can't discuss doubts like from any book. Okay, if you have any doubt, you can just text it here. After the class, I will see and reply to you. Okay. Yeah, A intersection B. And this whole thing and his whole thing means this plus this plus this. All three region combined will be known as A union B. All three region combined will be known as A union B. So basically this plus this plus this means full region. Full region will be known as A union B. Full region will be known as A union B. I think so. We studied this much in the previous class. Okay. So everybody is clear with all these things. Can we move further? Okay. Nice, nice, nice. So we have done union of a set. We have done intersection of a set. We have done difference of a set. We have done difference set. Okay. Symmetric difference of a set. Now we will do fifth point, that was disjoint set. Very easy. Disjoint set. As the name is stating, disjoint means there is nothing common between two sets. Okay. Let's say a commerce student is there and a science student is there. So commerce student will do BCom, BBA or CA after that. Science student will do BTech or might be BSc or something like that. So their streams are very disjoint. Okay. There is nothing common in between them. Let's say this set is A and this set is B. When there is nothing common in between two sets, they are known as disjoint sets. Disjoint sets definition can be A intersection B is equal to 5. A intersection B is equal to 5. There is nothing common between two sets. We can take example like odd numbers and even numbers. 1, 3, 5. Odd numbers are there and even number can be taken as 2, 4 and 6. So there is nothing common between A and B. So A and B are known as disjoint sets. is this clear to everyone? Disjoint sets. When there is nothing common between two sets, they are known as disjoint sets. Okay. Let's move on to sixth point. So sixth point is complement of a set. Complement of a set. Okay. Complement of a set can be represented as let's say A dash or A and C is written on its power. Okay, so this can be read as A complement. And what is A complement? So let's say this is a universe and this is set A. So everything outside A will be known as A complement. Everything outside A is known as A complement. So basically, A complement, number of element in A complement can be written as total element in universe minus total element in A. A complement is universe minus A. Okay. So if you want to check, we can take many example like complement of number of boys in a class will be equal to number of girls. Complement of number of boys in class will be equal to number of girls, because from total if we remove number of boys, what is left? Number of girls. Okay, is this clear? Complement, A complement means outside A but obviously inside universe. Okay, so you can learn some properties here. A complement will be again equal to A. Complement is again equal to A. Correct? Complement, like A complement is universe minus A, that's its outside thing. Again taking complement will make it inside thing. Okay? So complement is equal to A. Yeah. And we have written here, let's say, I will explain by other examples also. So this was A set and this was B set. So this area was known as A minus B. It is known as A minus B. Inside A, we have taken out all the element common to B. A minus B. Okay. So this area can be written as it's inside A but outside B. It's inside A but outside B. So this can be written as A intersection B complement. It can be written as intersection B complement. Means inside A and outside B. Okay. What this region will be known as? Can anybody tell? Similarly, by this logic, what this region will be called as? Green one. It's inside B but outside A. It's inside B but outside A. So then this can be written as B intersection A complement. B intersection A complement or B minus A we have already done. Okay. So in yesterday's things we can add on this thing, that this can be again written as it's inside A but outside B. So A intersection B complement or B intersection A complement. So three things. This became three things. Okay, very good. So complement is very easy. What is name? Sadik. Sadik is asking complement explain again. Okay. So you might have done it. So complement means outside A. Complement means outside A. A complement will be known as outside A. If this is set A complement is outside. If this was set B, everything outside B will be known as B complement. Okay, understood, Sadiq? Okay, nice. So everybody got it. So please write these things. Then we will move further. Over, sir. Okay. Nice. Let's move. Okay. Now we will study some theoretical parts. Then we will go more deep in Venn diagrams. Okay. Sir, what we call that near disjoint set? Phi. That is known as phi. 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 This letter is known as phi. Okay. So let's write fundamental laws of algebra of sets. Fundamental laws, like the very basic laws. Okay. So first one is idempotent law. First one is idempotent law. Idempotent law means whenever we are taking A union A, what will be A union A? Tell me. What is A union A? Obviously, it will be A. Or A intersection A, it will be again A. This very basic law is known as idempotent law. When you are taking union or intersection of a set with itself only, it will remain the same set. Okay. Let's move on to next law, that is known as identity law. Identity law. Here, A union phi is equal to how much? We are doing set A union phi. Again, it will remain A only. Phi means nothing. So A union phi. And what is A intersection universe? This is universe. Again, it will be A. It's very easy. It's very easy. But naming you don't have to remember. You have to remember only the concepts. That A intersection A is A union A is. Okay. Next one, commutative law. Commutative law. Commutative law means A union B is equal to B union A. We can interchange. A union B, obviously 1 plus 2 is equal to 2 plus 1, something kind of that. A union B is equal to B union A, and A intersection B is equal to B intersection A. Both things are same. A union B is equal to B union A, and A intersection B is equal to B intersection A. Okay, let's move on to next one. Associative law. Associative law. Associative law means A union B union C. Okay, A union B union C. What we can do? We can interchange the brackets. We can write it as A union B union C. So what this means is, first we are doing A union B, we are getting some answer, and we are doing union with C. And here what we are doing? First we are doing B union C, then we are doing union with A. Okay. So this is known as associative law. Okay, nice. So A intersection B intersection C. Obviously we can do A intersection B intersection C. A intersection B intersection C. Okay. Let's move on to next one. Next one is distributive law. Distributive law. Some students face difficulty in this, so please see it properly. A union B intersection C. When I will open this, so A will be union with B. A union B middle sign is intersection, and A union C. A union C. A union B intersection A union C. Okay, I will take one more example. Let's say A intersection B union C. So what will it become? First we will do A intersection B. So first we will do A intersection B, then union A intersection C. Union A intersection C. Understood? Okay, so please write all these laws, then we move forward. Okay, done. So let's write a new property, and it's a very important one, sixth one. This is known as De Morgan's law. De Morgan's law. It's very useful. Okay. Okay. So De Morgan's law. So De Morgan's law is A intersection B complement. What we are doing? A intersection B complement will be equal to, this complement will go inside, it will become A complement, intersection complement will become union, and B will become B complement. So A intersection B complement will be equal to A complement union B complement. Okay. Now we can take this thing also. A union B complement. Again complement will go inside. So A complement union will become intersection and B complement. A complement intersection B complement. Okay. So De Morgan's law is there. It's very useful. We have to remember this thing properly. Okay. Understood everyone? De Morgan's law. Okay. So let's move on. Let's move on. Let's study some more properties. Okay. So these are some important results. Okay. We have to remember. We don't have to mug up. Okay. We have to remember these results with the help of Venn diagrams, because somewhere they will be used. So I will explain each and every by using Venn diagram. So our Venn diagram will also become strong here. So let's start with first one. Let's start with first one. Okay. So A subset of B. This is sign of subset. We have done subset. A is subset of B. This implies that A union B will be equal to obviously B only. A is subset of B means A is part of B here. So I will just explain this by Venn diagram. See it properly. If A is subset of B, so let's say this is B, and A is subset means A is its part. A is part of B. Correct? So A union B, when we are adding A and B, what we will get? Obviously, we will get B only. Yeah, you should copy. I will just explain each properties with the help of Venn diagram. You have to copy one by one. Like after one, copy its proof. After two, copy its proof. Okay? Don't copy all at once. Copy one by one. First thing, then I will prove it by Venn diagram. So you should do like that only. So A union B will be equal to B. And what is A intersection B? Obviously, common part will be this much only. So A intersection B will be equal to A. Got it? So A union B is B only. We can take it by examples also. Let's take A set as 1, 2 and B set as 1, 2, 3 and 4. Here are only 1, 2, and here will be 3 and 4 somewhere. 3 and 4. So A union B. When you will do A union B, what you will get? Obviously, we will get 1, 2, 3, and 4, which is equal to B. And when we will do A intersection B, we will get 1 and 2, which is equal to A. So A union B, there is no C, there is subset sign. That is subset sign, that is not C there. Okay. So A union B is equal to 1, 2, 3, 4, which is equal to B, and A intersection B is only 1 and 2, which is equal to A. Correct? Okay. Please write it. We will move on to next one. Sadik is again asking why B is not overlapped. B is not overlapped because B is, you have not said, I think it's a subset. Subset means A is part of B. Okay. Like you are part of the family. Can you be bigger than the family? Answer will be no. You will always be a part of family. So he is similarly, A is part of B only. Identity law. Identity law means A union A is A intersection is A. Aniket. Shubham Reddy is asking when will college begin? 1st June. I don't know Akshat what is portion right now. Portion is not. See, whatever we have studied, all will come. Nothing like that. Okay, let's move. So this one is done. I am removing this one. Take a screenshot or copy it. Okay. Let's do second one. A minus B. If you remember, we have already done A minus B. Okay. A minus B is A minus A intersection B. A minus B is A minus A intersection B. We have done it n number of times. I will show it again. See here also. Here also what we have done? A minus B. This part was A minus B. Here also we have written A minus B is full A minus A intersection B. Okay. Full A minus A intersection B. Okay. So A minus B is equal to second one. I will write it here. So what we are doing for A minus B, this portion is A minus B. This is A, this is B. This portion is A minus B. So what we are doing from full A, we are subtracting this part. So we are subtracting what? A intersection B. So we are getting A minus B. Correct? Okay. So let's do the third one. A minus B union A intersection B. Now you can easily see this is A minus B. This portion is A minus B. I will color it. I will color it by different color. So let's say this is A minus B portion here. This portion is A minus B. Everybody is understanding this one? Yes. Okay, color it properly only. So this portion is A minus B. Now it's properly done. So this portion is A minus B. Now we are adding this portion, red one. In the third one, what we are doing? In the third one, what we are doing? A minus B union A intersection B. So A minus B was green one. We added A intersection B. So that became full A na? That became full A part. So A minus B union A intersection B will become A. Okay. So you don't have to mug up the formula. Just visualize the Venn diagram and you will understand each and every step. Okay. So one done, two done, three done. Okay. Fourth one. A minus B. A minus B. We all have understood what is A minus B. This region is A minus B. Let's mark this region also. This is B minus A. This region is B minus A. Okay. So this region we have also marked. This is B minus A. So what we are doing it here is A minus B union B minus A. Okay. So A minus B union B minus A means we have added green part too, pink part, and we are adding the red part also. So we got all the three parts here. All the three part means A union B. A union B. We have already done that. That is A union B. Very good. Now comes the fifth part. A minus B union B minus A. Is it correct or not? A minus B is equal to union B minus A. Correct. Obviously. So this green part and this pink part combination, green part and pink part combination will be equal to total minus red part. That will be equal to total minus red part. Total is A union B minus A intersection B. Correct? Okay. Now let's move on to A minus B union B. So A minus B was green part and B is this whole part. So see this one, sixth one. Arjun is saying to draw two different because he is getting confused. So we will draw it. So this part is A minus B here. So this part is A minus B, obviously. And union B, we have to add B to it. We have to add full B to it. When we are adding A minus B to B, okay, A minus B to B, we will get the full area. And full area is known as A union B. Understood, Arjun? So we are getting A union B. Okay, this is very basic. Nothing to be said in this. A intersection phi will be equal to phi. A intersection phi will be equal to phi. So everybody have written this. Can we move further? Okay. Okay. Take 1 minute more. Sharon is asking fourth one again. Okay, let's do fourth one again. So A minus B. Sharon, see it here. A minus B. So I will take this color, let's say. So this is A minus B. We have already done what is A minus B? This part was A minus B. So I have marked it green. Then we have added B minus A. What is B minus A? B minus A is this part, correct? Now we are adding A intersection B. A intersection B is this part. So we got all the parts here, and all the parts is what? A union B. Okay. Kritika is asking third one. So A minus B. See, A minus B is this part, and this is the intersection. So when we will combine these two, what we will get, Kritika? A here. A minus B union A intersection B is equal to A. A minus B was this part. A minus B was this part. A intersection P is this part. So when we combine these two, we will get A. Okay. Got it? Okay. Let's move further. Let's move to now three set Venn diagram. Okay. Let's move on to three set Venn diagram. Three set Venn diagram. Okay. So we have studied two set Venn diagram properly. Now we are moving on to three set Venn diagram. So here we are having three sets. One set let be A, one set let be B, and one set let be C. So these are the three sets. Okay. For that, we have to create formulas now. Okay. So obviously, whenever I move to the next slide, student will ask go to previous slide. Whenever I am on the previous slide, they will say to go to next slide. So this is a repetitive process. So please take a screenshot. Okay. Now see here. For three set Venn diagram, let me explain you one more formula. Then we'll go to three set Venn diagram. Then it will be much easier for you. So we are doing formula of A union B. Let's say we are doing formula of A union B. So this was A, this was B. So think it like we are putting two plates. This is A plate, this is B plate. And if you will see from the top, it will look like a single plate. Yes or no? It will look like a single plate. But from this view, you can easily see this part, this some fingers part are overlapped. So this part is coming how many times? Two times. And that overlapping part is known as A intersection B. Okay. That overlapping part will be known as A intersection B. So if we have to find the formula of A union B, what we are doing? We are adding A. Now we will add B. We have added A, we have added B, but this part have came twice. This part came twice. So I have to remove this part one time. So I have to remove this part one time. So I will do minus n of A intersection B. So what I will do? Minus n A intersection B. Everybody understood this thing? A union B will be equal to A plus B minus n of A intersection B. Because A intersection B has came twice. I think it's clear to everyone. So this is the, let's we can say, only formula for two set Venn diagram which will be used again and again. So A union B is equal to n of A plus n of B minus n of A intersection B. Okay. So let's move on to three set Venn diagram. Let's move on to now three set Venn diagram. Okay. So again, see, I have to mark the regions. So see it very properly. Mark the regions. This region will be called as, this region will be called as what? This thing. This region will be known as A intersection B. It's a common part of A and B. So this region will be known as A intersection B. Just drawing it. Okay. So this will be known as A intersection B. Correct? Okay. Now this part will be known as this part. This blue part will be known as A intersection C. This blue part will be known as A intersection C. Correct? Okay. Now let's mark the third one. Let's mark it with green. This part, this part will be known as B intersection C. This part will be known as B intersection C. So A intersection B is the yellow one, A intersection C is the blue one, and B intersection C is the green one. Yeah. So naming will be like this only. It's common to A and B, so we have marked it as A intersection B. This blue part is common to. Forgot this B part. For when we are saying common to A and C, we will just remove the B part here. So A intersection C. Okay. Now you can see this central figure. This central figure you can see. In this central figure, everything is common. Blue part, red, sorry, blue, yellow, green. All three are coming. So this is known as A intersection B intersection C. All three are coming here. So A intersection B intersection C. Okay. A intersection B intersection C. Is it clear to everyone? Very good, very good. So see. So we will derive the formula of A union B union C from this logic only. A union. Don't mug up the formula, okay? It's a long formula. So if you understand the concept here, it will be very easy for you to understand. So what is the formula of N of A union B union C? So first thing what we will do, we will put A, we will put B, we will put C. So we have put it three circular plates. So it will be N of A plus N of B plus N of C. Everybody is clear? We are putting A, B, and C. Okay? A, B, and C. Three plates like this. Okay? So obviously A intersection B will come how many times? Two times. So we have to remove it one time. So we removed N of A intersection B. Obviously B intersection C. This green part will be again overlapping by two things. So it's coming two times again. So we have to remove it one time. Minus N B intersection C. N here means number of elements, cardinal number which we have done in the previous class. Number of elements in B intersection C. Again, this blue part is coming two times, so we are removing it one time. A intersection C. Understood? Up to this, it's clear to everyone. We have added A, B, C, and A intersection B came twice, so we will remove one time. B intersection C came twice, so we remove one time. A intersection C came twice, so we removed it one time. So how many times we removed it? We removed it three times. Okay. So but you can see it, this part, A intersection B intersection C. It's coming in A intersection B also, B intersection C also, C intersection A also. So it got removed three times. So it got removed three times. And if we were having a plate like structure, so it was already three times. So one layer, two layer of B, three layer of C. And we have subtracted it three times. So it got totally removed. So we have to fill this place. So we have to fill this place. And for filling that place, we are again adding A intersection B intersection C. So again we are adding A intersection B intersection C. So how to remember this formula? How to remember this formula? That A union B union C will be A plus B plus C. This is twice, remove once. This is twice, remove once. This is twice, remove once. So by removing it three times, it got three times subtracted. So there is a blank space now. We have to fill that blank space. And how to fill that? Add it again. So we have added A intersection B intersection C. Correct, everyone? Okay. So let's move on to next formulas. Okay. So three formulas are there in this. Okay. You don't have to mug up any of that. Otherwise, otherwise, I I think you will forget this very soon. Okay, so just remember by the logic A plus B plus C. This part came twice, so removed it once. This part came twice, removed it once. This part came twice, we removed it once. So central part got removed three times, so we are adding it one time. Okay. So let's move on to next one. Uh, yeah. Second formula for exactly one of A or B or C. Formula for exactly one of A or B or C. Okay. So let's do it. So again we will draw a small diagram of set A, set B and set C. Okay, set A, set B and set C. Exactly one means this region. Exactly one means this region. This region is only A. Only A. This region will be only B. And this region will be only C. Is everybody clear with this terminology? Only A means no part of B and C are coming there. Only B means obviously there is only B only there. No part of A and C are there. Similar with only C. So how to get this part? If you will think about this, how to get only A part? So if you will see it properly, this part is coming how many times? This part is two times. This part is two times. It's coming due to A also, it's coming due to B also. So let's make a formula. Obviously, we will do first n of A plus n of B plus n of C. We added A, we added B, we added C. But this green part should be removed how many times? Two times. Is everyone clear with this? Because we don't need that part, not that once also. So we have to remove it how many times? Two times. So we removed two times A intersection B. Similarly, how many times to remove this part? B intersection C. How many times we have to remove this part? Two times. So we will remove it again two times. So two times B intersection C. Again, this part also, A intersection C also, how many times to remove? Two times. So we are removing 2 times A intersection C. But see here, if you are removing the green part, so the common A intersection B intersection C, this common part got removed how many times? This common part totally due to these three. This common part got removed how many times? 2 times for A intersection B, 2 times for B intersection C, 2 times for C intersection A. Yes, very good, Jitesh. It got removed 6 times, correct? So it got removed 6 times. And how many times it was already there? And how many times it was already there? We removed it 6 times. And how many times it was already there? 3 times. Because when we put A, B and C, it was how many times there? That portion was 3 times there. Okay. But we removed how many times? 6 times. If it was already 3 times there, how can we remove it 6 times? So we have to add it. How many times? 3 times. So we have to add it how many times? 3 times. Okay. Because it was 3 times there and we have removed it 6 times. That is more we have removed. So we have to make it 0. Plus 3 minus 6 is minus 3. To make it 0, we will add plus 3 again. Correct? Plus 3 minus 6 is minus 3. So to make it 0, we will have to add plus 3 again. So again, I will write the formula. How to remember this thing? Exactly one of A or B or C. So first we will add A, then we will add B, then we will add C. A plus B plus C. Okay. Now this green part came twice, intersection part. So we are removing 2 times the intersection part. So 2 times A intersection B, 2 times B intersection C, 2 times C intersection A. Correct? Now the central part got subtracted 3 times. Sorry, 6 times. 2 due to this, 2 due to this and 2 due to this. So it got subtracted 6 times, but it was there for only 3 times. It was there for only 3 times. So we have to add this 3 more times to make it 0. Okay. So our formula is A plus B plus C minus 2 times A intersection B, 2 times B intersection C, 2 times C intersection A plus 3 times A intersection B intersection C. Okay. So this is formula for exactly 1. Now let's do the formula for exactly 2. Now let's do the formula for exactly 2. Can we? Okay. So third formula is for exactly 2 of A, B, C. Exactly 2 means which region? See, I will mark it by blue color. This is exactly 2. It's very easy. It's very easy. From A intersection B, remove the common part. Remove the common part. A intersection B, remove this part. Okay. So from A intersection C, remove this part. B intersection C, remove this part. So very easy. So n of A intersection B plus n of B intersection C plus n of C intersection A. This plus this plus this. So this part came 3 times. So we have to remove it 3 times. So 3 times A intersection B intersection C. So by that logic we will get the blue part. Because in that blue part only 2 things are there. A intersection B, B intersection C and C intersection A. Everybody understood this thing? A intersection B, B intersection C and C intersection A. Okay. So these are the Venn diagram formulas for three set Venn diagram. Tomorrow we will do questions on this. Okay. So some JEE main level also. So it will be a very interesting class because problem solving will be there. But you have to remember all these formulas. Okay, all these formulas. How to remember? Remember by drawing Venn diagram. Otherwise, you will feel very much difficulty in remembering these formulas. Correct? Okay. So today we are having 3-4 minutes, so we can have quick discussion of what are the difficulties you are facing. Yeah, please ask. Shubhan Reddy is asking K2. I don't know about K2. Ask your centers na when they will open. They will tell you correctly only. Okay, last part. Last part is we have to take this blue part here. है ना? Oh, exactly, because in this only A and B are here. Only A and B in this blue part. Yes. So how to take this blue part from this full part? We are subtracting the common part. So A intersection B, we have subtracted A intersection B intersection C. From this A intersection C, we are subtracting it again. So B intersection C, we are subtracting it again. So we are getting that thing. Okay. Okay. We can't do that, Apurva. I don't know what is the. I will just get the information about that. Apur is saying that 28 classes are starting in 30 at my hostel. Okay, classes are up to 30. Which branch I belong to? I belong to Himayatnagar branch this year. Yeah. Only set A. Naman, you can take the logic here. है ना? You can find only set A. After college starting, they will start from fundamental of mathematics. That is, log will be there. Obviously, log will be there. So they will be starting from log kind of thing. Okay. Any other issue? Nah, these topics are not included in regular classes. Books and material, obviously, you will get from your respective centers. Every center is good, Shobit. Okay. So I'm just sharing the notes again. Okay. So one question will be from, obviously, will be from sets. One question will be from this chapter. Sai Rishi is writing calculus. What to do with that, Sai Rishi? Which campus you are in, Shoaib? No, we don't. We will not have sets in the main classes. I can't come anywhere. Already good teachers are everywhere. Yeah, I know, Jitesh. Okay, Suresh. ECIL is a good campus. I can't send physics PDF. How can I send? So, sir is sending you the today's class PDF. Okay, it's in the chat box now. You can download it. Equality. Inequalities will be started. Yeah. Sai Rishi is writing chapters name. Okay. So again, tomorrow we will meet and we will start problems on this. Keep revising and just enjoy. 2, 3 more days to go. Then your hectic schedule will start. You can call it hectic if you're not studying, otherwise, you will enjoy a lot. Okay? Bye, everyone.
Good morning, students. How are you? Hope everyone is doing good, fine. Let's begin our session. Yesterday, we were discussing system and frame of reference. The chapter was Newton's laws of motion, and we discussed how to decide what our system is and also the frame of reference. Just a brief recap of that. We said that system is either a body, a collection of bodies, or a part of body under consideration. At a time, if there are multiple bodies present in the system, then we pick either one or two of them as per our requirement, and that's how we decide what our system is, right? The significance of system is that until you decide what is your system, you cannot decide uh, what is an external force or what is the internal force. All right. So let's take a couple of examples on that and then let's proceed. Suppose if I say that this is a person, okay, and let us say this is the earth. Looking to the proportion, this person seems like a monster. He's so huge. He's so huge in comparison with the earth, you can see. Anyways, right now, if I look about the forces acting on the man, I'll say there is a force of gravity being exerted by the earth. If I take the man as my system, in that case, the gravitational force is an external force. Okay, but if I say no, let us treat both the earth and the man as our system. So if I say man plus earth becomes our system, now this time this Fg will become internal. So I hope it's a simple illustration to understand what is an external force, what is an internal force. That depends upon your choice of system. Okay, let's take one more case. Let us assume that on a table you put one block A, now you put one more block B, and now you start exerting some force F from the left side towards the right side on the block A. Okay, so let us assume F is exerted by me. Now, what do we expect? What will happen? If I exert the force on A, will A move separately or will A move along with B? What do you think? Should they move together? Yeah, because B is kept in the pathway of A. So if A has a tendency to go to the right, it will certainly push the block B together. So actually A and B both are moving. So if you think about the block B, should I say B is moving because of the force exerted by the block A? Can we say so? The motion of B happens because of the force exerted by A on B. And also, if A is exerting some force on B, then yes, of course, B will also exert an equal and opposite force on A. This statement comes from Newton's third law, although we haven't discussed it, but I'm sure we remember every action has opposite equal reaction. So if A is exerting some force on B, B will also exert the equal and opposite force on A. I assume you are aware of that. If not, then just listen to it. That's Newton's third law. In nature, forces are never made in what I can say. Isolated forces are not made in nature. If one body is exerting a force on the other, that other body will also exert equal and opposite force on the first one. So that's how if A is pushing B on the right side, B is pushing A on the left side. If I think about the horizontal forces present here, then if I think about A, now I will say A is experiencing one external force. I said this is me. So this F is given by me and this F is given by, uh, I'm sorry, I should have written it as B, force by E on A. So A is experiencing these two forces and B is experiencing just one force in the horizontal direction. Right now, I'm not talking about the vertical direction. If the gravity is there, then there will be some forces in the vertical direction. We are not going to discuss that now. We'll take it a little later. Anyways, horizontally speaking, now these are the forces. Now, if I say that A is my system, if I take A as a system, then I will say F and F by B. Both these forces are external. If I say B is my system, if I say B is my system, then force exerted by A on B is the external force. But if I say my system is A plus B, if I take A plus B together as a system, now look here. When you show A and B as one system, then the force exerted by A on B was this way and B on A was opposite this way. But you can see both these forces are arising from inside the system. These forces are not coming from outside, they are present within the system. So this time, these forces will become internal forces. That's why if I say A plus B is my system, in that case, F is an external force. That means the force which I was exerting. But the force by A and the force by B, these two will become internal force. Okay, so this is how we decide whether a force will be internal or external, and our answer depends upon our choice of system. Okay, I am considering that there was no friction. Somebody has asked that won't frictional force work on it? True, frictional force may also be there. I was assuming that the surfaces are smooth. That's why I haven't considered friction here. Yesterday's notes, I'll tell the person here to share the notes by the end of the class. So I hope we are clear on this, how to distinguish between internal and external forces. All right. A and D cancel. Yeah, that also you can say these two internal forces will cancel each other. So now let's proceed. Now I assume that we understand what system is and what these frame of references are, inertial and non-inertial. Uh, a frame is inertial if it is unaccelerated, and from that frame you will always find that the law of inertia holds true. But if the frame is accelerated, then we say it is non-inertial, and in that case you cannot identify or you cannot verify the laws of inertia or even the other laws. Let's take an example for that also. If there is a chamber and the floor is perfectly smooth, there is no friction here. You put a block here and you yourself are, let us say, standing in this position, right? Let us assume that this chamber is kept on another smooth surface. Initially, I am assuming everything is at rest. The chamber, you, the block inside. Now, what happens if I start pulling this trolley? If I start pulling this structure, what will happen? That this block would not be able to move from its position because there is no friction. See, if I put something on my hand and if I'm moving it like this, you can see I'm not taking a grip on the pen. Pen is just kept on my hand. So now if my hand is waving like this, the pen is also following the motion of my hand, and it happens just because of the friction. If there was no friction between my hand and the pen, in that case, even if I move my hand very slowly, the pen would have stayed at the same point, and at a certain point, it will fall down. So, when these things happen, when such type of motion that you put one thing on the other and you move the lower thing, instead of pen, suppose I have taken this remote in my hand. So, you can see in this position that if I'm moving my hand this way, this motion of the remote is happening just because of friction. Okay. Uh, if there was no friction, if I would move my hand slightly, it would have fallen down. Now, what this friction is? See, friction we say is a contact force. Friction arises between the two surfaces where there is a contact. You can see there is one surface of my hand and there is one surface of the remote. Now, when these two surfaces come in contact, when there is a pressing force between them, somehow the remote is pressing my hands down because of the gravity. Okay, so now there is a pressing force between the two surfaces. Remote is pressing my hands down, my hands are pressing the remote up. When this force is present at that situation, whenever there is a tendency of relative motion between the two surfaces, the friction has a tendency to oppose it. So in order to oppose the slipping, the friction will always try that the two bodies go together, because friction would not like the presence of slipping wherever the surfaces are in contact. So we say friction is a self-adjusting contact force which has a tendency to oppose the relative motion between two surfaces in contact. Okay. Right now, I have given just a brief outline of friction. You should know that the second part of the chapter, laws of motion, is in itself a separate chapter, and that is friction. So we have a whole dedicated chapter on the friction where we will understand this thing in more detail. Right now, we should just have a broad idea of it, that what is the main role of friction in these types of motion. Well, now coming back, if this surface of the trolley is perfectly smooth, when you pull this trolley forward, what will happen? This block will not move from its place, but since you are in contact with the rear wall, now the wall will push you, and that's why actually you are going to hit the block, right? My this statement is coming as an observer who is standing outside. Right now, you're also watching on your screen. So if you are looking at it, you are actually an observer also from outside. Now I said this is you. Okay, let's avoid the confusion. Let us say this is some Mr. X. You are outside, Mr. X is inside the trolley. So now, if you are exerting a force on the trolley, Mr. X will also be pushed by this rear wall, and the trolley and Mr. X, they will go with a common acceleration as seen from outside, but this block will not move. If you watch it from the outside, the block will not move. But my question is that if Mr. X is the observer, or if you imagine that in place of this Mr. X, if suppose I install a camera on the top, suppose I say this structure is a camera. So what will the camera show? Now try to visualize what the camera will show when this force is sufficient to take the man and the trolley ahead. This camera will show that the block is going to the left. So if you see the footage shown by this camera C, what will it show? It will show that the block was kept here and suddenly it started accelerating in the backward direction. This is what would be visible when you watch the block from that camera. Understood? You will not have the same opinion. If you are sitting outside, you will never agree with this statement that the block is accelerating backwards. You will always say, no, block is at rest. The trolley is going to hit the block, but somebody who is here, somebody who is attached with this frame, he will never agree with you. He will say, no, I am at my place. The block is coming and the block is going to hit me. Okay. So, if you want to speak it this way, that what is the reason behind it, you should understand the observers are in different situations. Whenever you observe a phenomena, your own situation will decide the outcome of the motion. What we are able to see will depend upon how we are. And when I say how we are, I mean where are we situated? Are we at rest or are we in motion? And if we are in motion, are we in acceleration or are we in a uniform motion? All right. Whose statement is correct? Palak, both statements are correct. It is not about being correct or incorrect. We say even that the motion is also relative, right? The motion is also relative, and that's why if one person says that something is moving and another person says that no, it is at rest, they may be equally correct depending upon how they are situated. So, if you look at the footage of this camera, uh, you might start thinking that Newton's laws are not true. It sounds like a very big statement, but yes, if you are in this frame, if you look at the footage of this camera, you would see that maybe the Newton's laws don't precisely apply here. Let me explain this. Now, through this example, I will be narrating all the three laws of the Newton's, and we will see how those three laws cannot be verified in this situation. Specifically, you are looking at the footage of this camera. Okay. Now, number one, what does the camera show you? Camera show you the block was at rest, and suddenly it starts accelerating, right? But there is no visible or invisible force for that motion. So now try to understand that the first law says a body will continue in its state of rest or uniform motion until and unless an external force act on it. So now look at this situation. There is no external force and still the block appears to move. Got it? There was no external force and still the block appears to move. Doesn't it goes against the Newton's first law? Right? Second law. Second law says the force, external force is directly proportional to the rate of change of momentum. And after a couple of steps, we get F equals ma. So F equal to ma is an equation which we obtain from the Newton's second law. Okay. You see here, there is no force, but there is acceleration. Right? There is no visible source for the block, and still the camera shows the block to accelerate. So this makes our belief in the Newton's second law weaker. Now come on to the third law. Third law says that for every action there is equal and opposite reaction. or we can say it that way, if one body exerts some force on the other body also exerts the same force on the first one. The forces are never made in isolation, they're always made in pairs. We can speak up the conclusion of the Newton's third law in this type of phrase also, that in the nature, forces are always made in pairs. One body cannot just be involved with exertion or experiencing of one force. If it exerts or experiences one force, a similar thing has to happen on other also. Now, even that thing is not visible here. You can see just one block starts moving. Now, what is action, what is reaction? You just can't speak about that. Got it? So, this is why we say that such a frame is non-inertial. I hope now you better understand the meaning of this term, non-inertial. This is a frame from where the idea of inertia doesn't appear to be true, isn't it? This is a frame from where you cannot verify the Newton's laws. So, when we discuss about the Newton's law, we will first make it a condition that all the observations are done from the inertial frame of reference. And when I say inertial frame of reference, I mean somebody who is not accelerated. So, without acceleration, if there is an observer and he observes something, then that observer will become an inertial frame. So, the Newton's laws will be valid, or Newton's laws can be verified only from the inertial frames, right? Now, I would like everybody to just take a note of this. If I'm not wrong, broadly, all of us know what the Newton's laws are. Newton's first law, second law, third law. Probably all of you would have read that. Uh, Before the laws, now what we have discussed just now, or including our yesterday's discussion, we have tried to understand under which conditions will these laws be applicable, and under which conditions you can't apply them. Got it? So, any rule, any principle, any idea, of course, it has to be understood that how it can be applied, but it is equally important to understand where it can not be applied. You must understand those situations where a certain rule or a certain conclusion is not applicable. Got it? And that was the reason that even before starting the Newton's laws, I started these two terms, system and the frame of reference. So now that I'll be coming towards Newton's laws, I just want to declare that we will be assuming that we are talking in inertial frame of reference. When I say we are talking, I mean the situations which we will be taking, the illustrations which we'll be taking, the real life examples which we will be taking, we are assuming that they are going to be observed by an inertial frame of reference. That is the main thing to be kept in mind. We might not repeat it in every question, but this is a presumption. Uh, we assume that if everybody knows that if you are applying the Newton's laws, you are working from an inertial frame. Okay? So, now let's formally discuss the Newton's laws one by one. I won't spend too much of time on it because I'm assuming that you people have at least idea of what these are. Number one is Newton's first law. Number two is Newton's second law. And number third is Newton's third law. Of course, the laws should come in the sequence of 1, 2, 3. But there is a funny thing. In mechanics, we have these first law, second law, third law. In thermodynamics also, there are such laws. But the numbering doesn't go like first law, second law, third law. In thermodynamics, the numbering goes like from zeroth law of thermodynamics. That is the zero order law of thermodynamics. Then the first law, then the second law. So, see, sometimes even the counting doesn't start in the same way. Well, it's just a light side of it. Now, what the Newton's first law says. Newton's first law, we can say, is actually highlighting the impact of force. Newton's first law signifies the application of force in any situation. First law says that every body will continue in the state of rest or uniform motion until external force act on it. So, this first law I can write as if it says that if net external force, if net external force on a body is zero, in that case the statement says it will continue in the state of rest or uniform motion. Now understand one thing, if I say a body is at rest, not for a moment, for a certain duration of time. If I see a body at rest, there is a tube light which is at rest. So I can say for that tube light, the acceleration is zero, right? And also, if a body is moving with a uniform velocity, if the velocity is not changing with time, I will again say the acceleration is zero. So basically, the statement of the Newton's first law can be interpreted this way, that if net external force is zero, in that case, the acceleration of the body will also be zero. Right? If there is no external force acting on it, then it says the acceleration will also be zero. So understand one thing, when we speak about the mechanical state of a body, when we say mechanical state, that means is the body at rest, is the body in uniform velocity, or is the body in some accelerated motion. So broadly, we can say these are the different types of mechanical states: being at rest, being with uniform velocity, having uniform acceleration, having non-uniform acceleration. So these are the different examples or the different situations in mechanical state. So a body has a tendency to maintain its mechanical state as it is. That means if it is at rest, it will stay at rest and it doesn't need any external help to stay at rest. Same way, if a body is moving with uniform velocity, then it doesn't need any external force to maintain that velocity. This is a natural tendency of the bodies to maintain their velocity. Since our life has been spent on earth, and on earth the friction is present everywhere, so that's why we may agree with the first statement that yes, bodies don't start moving on their own, but bodies stop automatically. I hope this is our day-to-day life conclusion. Maybe bodies don't start moving on their own, but they stop automatically. But when I say automatically, that only means that we are not doing anything. We are not trying to stop the body, but actually friction is present everywhere, and this friction is responsible to stop most of the moving things. If we could get rid of the friction, we would be in a better state to understand this statement. So that's why whenever we want to visualize that situation, whenever there is no external force, we prefer to think in such a way as if we are not living on earth. Let us say we are surviving in some outer space, and even when I say outer space, I mean we are so far away from our solar system, from all the stars, that almost the gravitational force of all the celestial bodies can be ignored. Okay? And yes, up to an extent, this statement makes sense. If you are very far away from most of the stars, from most of these systems, the gravity will be very small there, that can be ignored. So, whenever we say in the outer space, whenever such examples will be coming in the numericals, also you will see that in many places such situations are specified, that in outer space so and so happens. So when they say outer space, they actually want to create a situation where there is no external force. Yeah, I was saying that when you think about the first law, it says that bodies don't start moving automatically and bodies don't stop moving automatically. On the earth, maybe we agree with half the statement. We can agree that The bodies cannot start moving on their own. Bodies can stop automatically because that's what we have seen. If there are chairs placed in the room, they don't start moving automatically. But if I push one of the chair, it will move for some time, but it will stop on its own. I am not needed to stop the chair. But that doesn't mean that the chair stops automatically. If I did not exert the force, there was friction to do that. The chair was kept on the ground and there was a friction between the ground and the chair. That friction was responsible to stop it. So, usually when we try to think of a situation where there are no external forces, we prefer to say in outer space. So whenever a question goes like this, in outer space, this and this thing is done. So that outer space actually creates a situation where there can be no external force. If you take a mass and you take it very away from all the stars possible, let us say we even go away from our Milky Way galaxy and we are somewhere between two large galaxies, we are so far away, there is no external force there, no gravitational force. Okay, now in that situation, if you put a body at rest, it will stay at rest. If you just push it slightly, it starts moving and it will continue to move forever. It will continue to move forever, for years, years, years. If you can watch it, you will see it is still moving. So the first law highlights this tendency that to stay in the uniform motion is also a natural state of the body. Earlier, people were not able to agree with that. They argued that no, to stop the bodies, you don't have to be present. You only have to start the motion. Stopping happen on its own. So that was the mistake. When we say the stopping happen on its own, actually there we are ignoring or we are not able to identify the forces which are present. Got it? And since the forces are present in the air, on the ground, which can be responsible to stop it, so that's why it is not correct to say that the bodies can stop on their own. Okay, so that was about our first law. Second law. Second law states that the net external force is proportional. This is the sign for proportionality. The net external force is proportional to the rate of change of momentum. Rate of change of momentum. Now, momentum is a physical quantity defined as the product of mass and velocity. So the Newton's second law is defined in terms of momentum. It says that the net external force is proportional to the rate of change of momentum. So whenever you have a proportionality, F proportional to change in momentum, I am using delta P for change in momentum. When I say delta P, I mean P final minus P initial. You observe a body at some instant where the force starts acting. That becomes the initial momentum. Okay, and whenever the force stops acting, at that time whatever the momentum is, we are calling that as the final momentum. So initial and final, these two words are from our observation point of view. Initial momentum means when you first observe the impact of the force being delivered to the body, and P final is the last momentum when you observe and you expect that now the force maybe will be stopping acting. So the statement said F is proportional to rate of change of momentum. That means proportional to delta P by delta T. Delta T is some time interval. So F is proportional to delta P by delta T. And whenever you convert the proportionality into an equation, a constant appears. Now, that's a mathematical step. a mathematical reason that whenever there is a proportionality and if you have to convert it into equation, a proportionality constant will come. So we can write F equals K into delta P upon delta T. Okay. Now in our SI system, the value of K is taken as 1 and therefore we can write F as delta P by delta T. How are these proportionality constants decided, whether they should be 1 or they should not be 1? This discussion will also be done, but that we will do a little later. It's too early to talk about them. It may be even rather more confusing for you rather than be more enlightening for you. So let's skip it for now. Let's keep the suspense alive for some future classes. Uh, P is momentum and K is a proportionality constant. We say that K represents a proportionality constant. See, in general, whenever you say that a quantity X is proportional to Y, whenever this proportionality exists, you can always say X equal to some K into Y. Now, this K is the constant here. Got it? The value of this constant is usually determined experimentally. Okay. So for now, just keep it as short as this. Whenever two quantities are proportional and you want to convert it into an equation, you have to put a constant on them. Let's take an example. What do I mean by that? Imagine that you are driving. If you are driving and suppose you don't change your speed, you are driving on a straight line at a constant speed. So now tell me, under this situation, can I say the distance traveled by you will be proportional to the time for which you drive? Can I say that? You are not allowed to change your speed. So, if you are traveling with the same speed on a straight line, can we say that distance is proportional to time? How much distance you travel in 1 minute will be half the distance you travel in 2 minutes, will be one third of the distance you travel in 3 minutes. So, double the time, double the distance, half the time, half the distance. This is the simplest type of interpretation that we draw from this word proportionality. Okay. So yes, all of us have to be very clear about this term proportionality. Whenever I say X is proportional to Y, it means that if Y is doubled, in that case, X will also be doubled. Don't interpret it this way that if X becomes X plus 5, Y will become Y plus 5. That is not the idea of proportionality. Okay? The proportionality tells you that both the quantities will be multiplied by the same factor if you change the values. That means if x is doubled, y is doubled. If x is halved, y is halved. Fine. So I hope now you understand what do you mean by proportionality. So here I said f proportional to delta p by delta t. Then we had f equal to k delta p by delta t. And the value of k is 1 here. If k is 1, then f is delta p by delta t. And if I write this expression again, f is delta p by delta t. Now, delta p means delta of mv, change in the value of mass and velocity, divided by the time occupied. Then mass is a constant, so I can write this thing as mass into delta v, because we are expecting that the momentum changes only because of the speed, right? How can a momentum change? Momentum is defined by mass into velocity. So either the mass has to change or the velocity has to change. So we are assuming that the mass will remain same. It is not changing. only velocity is free to change. So I'm assuming delta V is the change in velocity. Now this change in velocity I can write as a V minus U. I'm using those symbols which we use in motion in a straight line. U for initial velocity, V for final velocity. So delta V means change in velocity. And when you divide it by time, then you can see this fraction looks like acceleration. So this is how we get this equation F equals ma from Newton's second law. All right. But everybody has to be a little cautious in saying this thing. F equal to ma is a conclusion that comes from Newton's second law. F equal to ma cannot be said as the Newton's second law. It is not the statement or even the definition of the second law. Uh, Read these two statements. Are we able to differentiate? I am saying F equal to ma is a conclusion that comes from Newton's second law, but F equal to ma is not the statement or it is not the definition of Newton's second law. Now see actually what happens that this is the only formula which we get from the Newton's second law. Right? Whenever you write Newton's second law, you end up with F equal to ma. So somehow we create a notion that F equal to ma is same as the Newton's second law. So if someone asks you what is Newton's second law, and if you give it the answer that according to the Newton's second law, the force exerted on a body is equal to the product of mass and acceleration. If you say this statement, this might not be very correct. Okay, we will not say that this is a correct way to define the Newton's second law. The correct way is that what we wrote earlier here, F proportional to dp by dt. You can say this is the basic statement for Newton's second law. When I say statement, of course, I mean that this expression, when you read out, then what would be your words? The net external force proportional to rate of change of momentum. So yes, this can be said as the Newton's second law, but not F equals ma. What's the problem? Why not? If this conclusion is coming from that one, why can't I say that this is also Newton's second law? The reason is that in coming through these steps, I was going through an assumption that the mass of the body doesn't change, right? And that is not true. That is not true in all cases. Yes, in many of the situations during the process going on, the mass of the system can remain same. And if the mass remains same, in that case, yes, F equal to ma or F equal to delta P by delta T is one and the same thing, right? But the mass can change. And if the mass is also changing during the process, then you can see the steps which I took, they will become incorrect. I have everywhere written m in the same value. I am assuming m remains same, and now I am saying that if m changes, then how can we incorporate this thing in one? So now let's take an example. How can the mass change? Imagine that I'm having a trolley. Okay, I'm having a trolley and there are wheels below this. Now I'm pushing the trolley. Let us assume I exert a force of 100 Newton on the trolley every instant. This trolley is empty right now. You can see there is some space inside, but nothing is filled here. So in this situation, let me say the mass of the trolley is 10 kg, right? The moment when I start exerting the force, rain starts falling. If rain starts falling, and since our trolley is the shape of a container, so some water will be stored into it. Then I'm showing that rain is falling everywhere. Now let us assume that in 1 second, let us assume in 1 second, 1 kilogram of water is added to the trolley. All right. I'm just taking an assumption that in 1 second, because of the rain falling into it, 1 kg of water is added to the system. Now, let us assume that I keep on pushing the trolley for 10 seconds. Okay. Now, if I am giving my force on the trolley, if we are entirely focusing on the trolley, should I say that trolley is my system? Yes, of course, trolley is my system. When we started the motion in the beginning at t equal to 0, the mass of the trolley was 10 kg. Now, since I kept on pushing the trolley for 10 seconds, and in every 1 second, 1 kg of water was added. So, can I say in 10 seconds, the extra mass of the water which will be added will be 10 kg? So by the end of these 10 seconds, you can see the mass of this trolley by t equal to 10, the mass becomes 20 kg, right? So there are situations like this also. I took the trolley as my system, and now the rain was falling, and because of the rain being added to my system, I would say my system has a variable mass. Got it? So, since mass can change, now tell me in this situation, if I ask you that question, okay, tell me the speed of the trolley after 10 seconds. Can you tell me what would be the speed of this trolley after 10 seconds? To get the speed of the trolley, you might think in terms of V is U plus AT. For acceleration, now you will think like F upon M. Acceleration is force upon mass. But now tell me which mass value will you take? 10 kg or 20 kg? None. You can't take any of them. In fact, this whole approach will become incorrect. Okay? So, this is a situation which we will be dealing at least 3-4 months from now. Even when we do the Newton's laws of motion, in those situations, we will not be taking the cases where there is a variable mass present. Because in the variable mass, the calculations go a little longer. I won't be able to solve this thing completely because it will need some ideas of differentiation, which we have not done now. I gave this example only to make you people understand that F equal to ma is valid only when mass is constant. And I gave you an example in which the mass is not constant. If mass is changing, then you cannot apply the equation. There is no reason that we should go with the mean value. Maybe initially it was 10 kg, later it was 20 kg. Let us take the mass as the 15 kg. Why? Why 15 kg? There is no scientific rule that, okay, wherever the values are changing, go with the average value. There is no rule like that. Okay. So, for such type of situation which I have narrated here, there will be a different way of approach. We will need little more maths, more understanding of the topic. Right now, let's come back. I want everybody to be clear on this idea that F equal to NA is a conclusion that we that comes from the Newton's second law, but F equal to ma is not the proper statement of the Newton's second law. All right. So if F equals ma is the Newton's second law, and F equals ma is the Newton's second law. If F is 0, should A be also 0? Right? If F is 0, then mathematically A will be also 0. Now tell me, doesn't this statement looks like the Newton's first law? Before few slides, I think I wrote the same thing when I was explaining this Newton's first law. Uh, 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 uh. Yeah, here only. See, for the Newton's first law, I wrote if net external force is 0, then acceleration is also 0. Now, this statement is coming in the Newton's first law, and the same statement is coming uh, from the Newton's second law also. So, doesn't it means that the Newton's first law's information, whatever the first law say, can actually be understood from the second law only? Or in other words, can I say that if I have the Newton's second law, I don't need the first law? Can I say that? Yes, we can say that. We use a typical type of phrase here. We say first law is either we say corollary or we say reiteration. Reiteration of second law. Corollary is something like you can say a gist or one of the conclusions which can draw from something. Reiteration is just like repeating. So sometimes it is said that actually the first law in a way is the repetition of second law. If you had second law and if there was no first law, it would not make any difference. Okay, so yes, we have three laws of Newton, but we say second law is the main law. It is the most dominant statement which is given. The first law can be understood from there. Whatever we say in the first law can be deducted or can be concluded from the second law also. Okay, so this thing is also something which we should be aware about. First law is the corollary or the reiteration of the second law. Now let's come on to the third law, Newton's third law. Okay, yeah, just before that also one thing. Since the Newton's second law says that F is equal to delta P by delta T. This F means net external force. If this net external force is 0, okay, if I say if F is 0, that means delta P upon delta T should also be 0. If a fraction is 0, I can say the numerator should also be 0. What is delta P? Delta P is change in momentum. P final minus P initial, and that should be 0. So if this is 0, I can say P initial equal to P final. So what we have done so far, we have said that if there is no external force present, in that case, the momentum of a body cannot change. Okay, whatever the momentum had value initially, that same value would be there in the end also. So if you observe a body, if you observe a system in which there is no external force present, then as long as if you keep on observing it, you will see that the momentum does not change. Okay, this statement is called as the law of conservation of linear momentum. Law of conservation of linear momentum. See, I have kept a linear in a bracket. Why? Because if someone asks you what is the law of conservation of momentum, if simply say the momentum, it is same as the linear momentum. If it is same, then why do we put a word linear? Because later on we will have one more similar term called angular momentum. So basically, yes, you can say momentum will be appearing in these two forms, linear momentum and angular momentum. So if it is angular momentum, that the angular word will be specified separately. If you only say momentum or linear momentum, that's one and the same. So what is the law of conservation of linear momentum? It says that if F external is 0, then momentum of a body remains constant. Okay, so this is the statement coming from a law of conservation of linear momentum. Now see, in our 2 years of preparation, there will be many conservational principles coming. You people have already studied some conservational principles, conservation of energy, uh, conservation of mechanical energy. I suppose that also comes somewhere in 9th or 10th. Let's all be very clear. When we use the word conserve, we actually mean the thing is not changing, right? Conservation also means the same thing, to preserve it, to maintain it in a same form. But mathematically, when we say conservation, so it is a simple word which means no change. If I say something is conserved, I simply mean it does not change. It will maintain its value for all the interval during which we are taking our discussion. Okay? So, when we say the momentum is conserved, we are saying the momentum maintains at a constant value. The momentum does not change. Fine. So this is what we mean by conservation of linear momentum. So force is the agent which is required to change the momentum. Okay. If force is not there, momentum will also not change. Fine. Now let's quickly talk about the Newton's third law. See, although third law is, I suppose, most famous law, most popular science laws, those even who are not science students, they also know what third law is. Every action has equal and opposite reaction. So this third law became popular just because by the choice of these words, action and reaction. Now see, uh, action and reaction are actually forces. Okay, why are the word action and reaction chosen? So that it becomes easy to understand. And whenever you try to make something easy, there is always a chance that it can be misinterpreted. And yes, it is the reality that in Newton's third laws, there are some confusions, there are some bottlenecks, there are some misconceptions which are created mostly because of these words action and reaction. Okay, so time is up for today. Anyways, when we say action and reaction, they actually mean a force. Uh, Action is one force by one body on the other, and reaction is the force by the second body on the first one. Okay, see, it will take a little time, maybe 5, 8 minutes or 10 minutes. I'll stop now and I'll send the person so that you can get that PDF. So that's all from my side today. Bye bye. Take care. Tomorrow we'll continue from the Newton's third law again. Okay. Bye bye.
Yeah, good morning everyone. How are you? So today we are going to continue with the topic. Yeah, good morning, Mister. So we are going to continue with the topic. Yesterday we are doing the temperature, not energy. Temperature we have to complete. Then we'll go into the energy part. So temperature. Yeah, we discussed yesterday how can we find the temperature. There are various instruments we are having. We discussed what is the instrument we are using for measuring the temperature. Anyone? Thermometer. Very nice. If you want to measure the temperature of a metals which are having molten metals having high temperature, hello, Mister. How can you measure? Yeah, gallium thermometer. Very nice, very nice, very nice. Ananya Kumari, good. Right, right. Namansi, good. Right, now continue guys. So, what are the various units we are having for measuring the temperature? Hello, hello, good morning, Salman. Yeah, Kelvin, units. Kelvin, Fahrenheit, Celsius, degree Celsius, Fahrenheit. Now, first, what is the thing we are going to do? We are going to do the interconversions. First, Kelvin is very important. Why Kelvin scale is very important? Anyone in the chat, you can write in the chat why Kelvin scale is important. Anyone? Yeah, Kelvin is SI unit. Very good. Kelvin is SI unit. Along with it, why it is important? Actually, if you are using Kelvin scale, on the Kelvin scale, negative values are not possible. The lowest temperature on the Kelvin scale is 0 Kelvin only. That is the lowest possible temperature. Okay. So, what is the importance of Kelvin scale? It is the SI unit. Very good. Also, on the Kelvin scale, the lowest possible temperature is the lowest possible temperature is the lowest possible temperature is 0 Kelvin. 0 Kelvin. Okay. So, whereas if you are taking degrees Celsius, what will happen? Negative values are possible. We are going to put conversion. What is a conversion? Conversion degrees Celsius to Kelvin. Kelvin is equal to degrees Celsius plus 273. Okay. Now, what we are going to do? What we are going to do? We are going to do the conversions. I will give you some questions based on this. We are going to do some conversions. Everyone ready? Please check once and get and tell me. I can't see the message. Anyone? Yeah. Right. Question. Nice guys. Convert 273 degrees Celsius to Kelvin. Second one. Convert 0 degrees Celsius to Kelvin. Convert minus 273 degrees Celsius to Kelvin. It is the lowest possible temperature on the earth. Lowest possible temperature. We call this as absolute zero. Absolute zero. Come on. First one. Yeah. So Kelvin we have to convert. Kelvin is equal to degrees Celsius plus 273. 273 plus 273. What is the answer? We are going to get. Yeah, 546. One person already mentioned 546. Very good. 546. Nice, nice. Next. Okay. Kelvin is equal to 0 plus 273. 273 Kelvin. Nice. Third one. What is third one, guys? Kelvin is equal to minus 273 plus 273, 0 Kelvin. It is the lowest possible temperature which we can measure. 0 Kelvin. That's all. It is the lowest possible temperature. Nice. One student already mentioned. Naman Singh mentioned everything. Manikumar, somewhere you went wrong, mister. First one, 283. Check once. Continue. Shall we move on to the next question? Convert Kelvin to degrees Celsius. Second type of conversions we are going to do. In that first bit, convert 723 Kelvin to degrees Celsius. B 298 Kelvin 2 degrees Celsius. Yes, answers? Yeah, already giving the answers. Okay, first one. What is the answer? Degrees Celsius is equal to, what will we get? Degrees Celsius is equal to 723 minus 273. What is the answer? In the chart, 460, 450, 450 degrees Celsius they are keeping. You can cross check. 450 degrees Celsius they are keeping. Is correct? 450. Manikumar, Bahrain Fatima. 450 and 25. Very good. 450 degrees Celsius. And what about second one? Degrees Celsius is equal to 298 minus 273. 25 degrees Celsius. What is 25 degrees Celsius? It is the room temperature. In chemistry, we will consider this as room temperature. Okay. STP conditions are, if you are taking STP conditions, they are 273 Kelvin and pressure is 1 atmosphere. Pressure. Temperature is 273 Kelvin. Room temperature, if you are taking, 25 degrees Celsius. Nice. So, second type of conversion we are going to do, converting the degrees Celsius into Fahrenheit. Okay. So, any doubt you are having? Shall we continue? Okay, right then. I am taking next page. Anyone copying? Now see here. Second type of conversion. Degrees Celsius to Fahrenheit. Fahrenheit is equal to 9 by 5 into degrees Celsius plus 32. Convert 37 degrees Celsius to Fahrenheit. Convert this now. Apply the formula. Whatever value I gave you, please use it now. .37 degrees I gave you. Anyone? Can I see the chart now? Okay. One Kelvin is equal to how much they are asking? 1 Kelvin. See, 1 Kelvin if they are mentioning, it is not 0 Kelvin, no, it is not negative value. Negative value of degree Celsius we are going to get minus 272 degrees we will get. Okay, so now what is the answer? 9 by 5 into 37 plus 32. First do this one division, multiplication, then addition. Give the answer. Apply the board mass rule properly. 99.6 or 101 they are giving. What is the proper answer? Not degrees Celsius, mister, in Fahrenheit. 101.6. Somebody is keeping 101.6. Check once. What is the proper value? Okay. Approximately tell me. What is approximate value? 7 5 35. Okay. Here 2 will be there. 7 5 4 20. 7.4, or if you are taking it as 7, how much it will be? 9 7 are 63. 63 plus approximately if you are taking also 63 plus 32, it will be 5 9. So somebody got 99 point something, no, 98.6. That will be the correct answer. Correct. 98.6 Fahrenheit. So do the second conversion. Do the second question, mister. Based on this, convert 40 degrees Celsius to Fahrenheit. Everyone, 40 degrees Celsius to Fahrenheit. Apply the formula. How to do it? 9 by 5 into 40 plus 32. 8 5s are 40. 9 8s are how much? 9 8s? It is 72. 72 plus 32. What is the answer? 72 plus 32. Answer. 104 Fahrenheit. Very good. Okay. So others by around we have to do means converting the Fahrenheit to degrees Celsius we are going to do. Akshay, no, ma. No, it's 109. 104. Check once again. See here. 5 8s are 40. 72 plus 32. 72 plus 32. How much it will be? 104. Akshay, fine. Yeah, Mayor Fatima, it's correct. Right. Continue then. Convert Fahrenheit to degrees Celsius. How to convert this? Degrees Celsius is equal to, what is the formula actually you are having? Same formula, one formula you can remember and you can use it as it is. See here, we know that Fahrenheit is equal to 9 by 5 into degrees Celsius plus 32. Now if you are bringing this side, it will be Fahrenheit minus 32. Okay, into 5 by 9 is equal to degrees Celsius. Apply the formula. Apply the formula now. Find the degree Celsius if the value given is 102 Fahrenheit. Second one is 103, 104 Fahrenheit. Come on, guys. Previous answer is 9 8s are 72. 72 plus 32. 4, 7 plus 3, 10. So this one's complete this now. Right? 1 or 2 Fahrenheit I gave you. Now we are converting this into degrees Celsius. Degree Celsius is equal to, what is the value they gave you? 102 minus how much? 32 into 5 by 9. 102 minus 32 into 5 by 9. What is the answer? They are giving 38.5. Naman Singh, 38.5 or 38.8 they are giving. Everyone cross check once. 38.8, 38.5. 38.8 degrees Celsius. Yes or no? Cross check. 102 minus 32. It is 100. 100 minus 30. It will be how much? 70. 70 into 5 by 9. 7 5 is 35. Means 350 by 9. So 350 by 9 means how much? Approximately 35, no? 350. 9, 9 3s are 21, 9 4s are 45. So 38, correct only. 38, something around 38 is correct answer. Do the second one also. 104 degrees Fahrenheit. 40. Everyone, I want answer from everyone. 40. Second one is 40. Second one, 102 minus 104 minus 32 minus 32 into 5 by 9. Answer. What is the answer? 42.4, 40. Check once everyone and give the answer to me clearly. Forty 40 degrees Celsius. Okay. So we know how to convert the temperature degree Celsius into Fahrenheit, degree Celsius into Kelvin, Kelvin to degree Celsius. Okay. Now what we are going to learn? We are going to learn about a very important parameter. Okay, that is energy. What is energy? It is a capacity to do the work. You know work. In the chat box you mentioned what is the formula of work? In the chat box, what is work? Formula of work. What is the formula of work? You can mention in the chat. Energy, it is the capacity to do work. What are the other relationships we are having? Energy is equal to power into time. How we got this? Power is equal to energy by time. From this we got this. Work is equal to force into displacement. Anyone mentioned in the chat? Anyone? Yeah, very good. Force into displacement. Wherein Dinesh? Force into displacement. Very good. Okay. Conversions we are going to do now. Yes. Conversions we are going to do now. SI unit is joule. Okay. What are the other units you are having? Calories. 1 calorie is equal to 4.184 joules. First we will start with this only. This is our SI unit. Our CGS unit is erg. Given the energy of a substance or anything, they gave you value as 2.2 joules. Convert this into 2.2 calories. Convert this into joules. Do it now. We already know 1 calorie is equal to 4.184 joules. Substitute now. Oh, sorry, Mr. Dinesh. What is the value? 2.2 calorie is equal to x. X is equal to 2.2 into 4.184. Answer, somebody already mentioned 9.2048. 9.2048. 9.2048 joules. 9.2048 joules. Fine. Fine then. Okay. Previous slide. Please copy it. One student is asking me previous slide. Just give me a second. He is checking that. Please complete this part. Okay, those who already completed, take this. Given energy, they gave you energy. How much? Given the energy of the substance in joules is some 106 joules. 106 joules. Okay? No, actually it is not the topic in interchemistry. What we are doing here, we are learning some of the important parameters. Actually, these are parameters in measurements. Okay, these are some variables, units we are learning. Apur Kumar, what is your doubt? Tell me. Apur, what is your doubt? Right. I will inform him. He is not there. I will inform. Now, what is the second question I gave you? I gave you in joules. 106 joules is the energy. Convert into calories. We know that 1 calorie is equal to 4.184 joules. Now 106 joules is equal to how much calories? Fine. X is equal to 106 into 1 divided by 4.184. What is the approximate answer? 25.33. Something they mentioned. 25.33 calories. Nice. 25.33. Chandrahas, nice. Ananya, very good. Fatima, Meher Fatima, nice. Okay, one more question. Now we are doing different type of conversions. Okay, we are converting calorie into joule, joule into calorie, and we know that For energy, the SI unit is, what is SI unit? SI unit is joule. Along with that, we are having other unit. CGS unit is erg. We have to convert erg into joule, joule into erg also. That also we are going to do, right? And also one more unit is having electron volt. So we are learning everything step by step. One electron volt is equal to 1.6 into 10 to the power of minus 19 joules. One electron volt is equal to 1.6 into 10 to the power of minus 19 joule. Convert 9.6 electron volts to joules. 9.6 electron volts to joules. Do it. Right? Now see this, I gave you 1.6 into 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. I gave you 9.6 electron volts, it is X. 9.6 into 1.6 into 10 to the power of minus 19 joules. So how many of you got the answer? 15.36 into 10 to the power of minus 19 they are mentioning. 15.36 into 10 to the power of minus 19. 15.36 into 10 to the power of minus 19. Check once. 15.36 into 10 to the power of minus 19. Maybe it is wrong. Check once. Because both it is 9.6, it is 1.6. So I think it is wrong. It may be 153.6 it will be. 1.538 into 10 to the power of minus 18. Okay. Everyone check the answer and tell me value. It's correct. Then we will do second one. Convert joules into electron volts. I am giving you some 100 joules of energy. We are converting into electron volts. We know that 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. I am giving you 100 joules. Or I am giving you 100 kilojoules. Use your mind. I am giving you 100 kilojoules. 100 kilojoules, not joules. 100 kilojoules means what? 1 kilo is equal to 10 to the power of 3 into 10 to the power of 3 joules. This is X. Substitute now and give the answer. Yeah, 15.1.5, no, 10 to the power of 19 I have taken, correct? Correct only, correct. Now do this one, do the current question everyone. This is only a basic part. 6.4242 into 10 to the power of 6 point. Why 6 point? See here, into 10 to the power of 6 this one, So x is equal to what? 10 to the power of 6 by, okay, 1.6 into 10 to the power of minus 19. This will be how much? If it is coming up, it will become 10 to the power of 25, 1 by 16. What is the value of 1 by 16? What is the value of 1 by 16? Or 1 by 1.6. If you are writing 1 by 16, it will become 10 to the power of 26 by 1 by 16. Tell me, what is the value then? 184. 0.0625 into 10 to the power of 26. How many of you got the same answer? 0.0625. Me, Himanshu Goyal, very good. Prachush Ghosh, Salman Khan, nice guys. Good, good. Very good, very good, very good. I will give one more question based on this. Then we will go to the erg conversion. Erg. Erg to joule, joule to erg. Nice. Almost got it. Very good, very good. Convert 1.6 into 10 to the power of plus 19 electron volts to joules. See this question clearly and do it. That much not needed. Dhanush, like that we should not write. Actually, in chemistry, you are going to learn about significant figures. Then you will understand that we should not write like that. 6 commas 250. No. It is a very difficult way to represent. We have to use n into 10 power n representations only. Okay, they are easy for us. Now see this. We know that 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. I gave you 1.6 into 10 to the power of plus 19 x. We are going to find the joules. So what is x? 1.6 into 10 to the power of plus 19 into 1.6 into 10 to the power of minus 19 by 1. Powers will get cancelled because it is minus 19, this is plus 19. Powers will get cancelled. So what is remaining? 1.6 into 1.6 by 1. What is the answer? 16. 16s are 256. But we are having decimal place also into 10 to the power of minus 2. So answer is 2.56. How many of you got the answer? Very good. Fatima, Tarun, Chandras, very nice. Very good, very good. Nice, nice. Nice guys, nice. Shall we move to the next one? Next conversion. Erg to joule. 1 erg is equal to 10 to the power of minus 7 joules. And what is importance of erg? It is CGS unit. SI unit is joule, CGS unit is erg. Okay. Now, given one value I am giving you, value of h is some constant. No need to think about what is h. It is unnecessary for us. Just I am giving you what is the value of h. Value of h is 6.626 into 10 to the power of minus 34 joule. Okay, I am not giving anything else, joule only. It is just some value. Now, convert this into ergs. What is the value in ergs? Do it. We know that 1 erg is equal to 10 to the power of minus 7 joules. Now, they gave you how much? 6.626 into 10 to the power of minus 34 joules x. Substitute that. Yeah, Planck's constant, but I am not going to teach here. Because if I say it is Planck's constant, it will be Joule second here. So that's why I don't want to say it is a Planck's constant. Okay. Right. So what is the value here? Nice, nice, Mister. What is his name? What is your name, Mister? Subhan Reddy. Very good, Mister. Now, what is the value of x? X is equal to 6.626 into 10 to the power of minus 34 by 10 to the power of minus 7. What is the value here? 6.626 into 10 to the power of minus 27 third. Check once. Right. Other way around. Given energy is 1.6 into 10 to the power of minus 19 Earths. Convert this to joules. We know what is 1 by 16. 1 by 16 value is fixed value. 0.0625 fixed value. Use it and do it. I will be waiting for the answers. Do it now, guys. Okay. We know that 1 erg is equal to 10 to the power of minus 7 joules. 1.6 into 10 to the power of minus 19 is equal to x. 1.6 into 10 to the power of minus 9 into 19 into 10 to the power of minus 7, that is equal to 1.6 into 10 to the power of minus 26 joules. How many of you got the correct answer? Very good. Dhanush, nice. Chandrahas, Anilya Kumari, good. And one more student is on the top. I can't see his name, but Chandras, very good. Chandras, Dhanush, very nice. Very nice. Fatima, right, good. Right. One joule is equal to Newton per meter. 1 erg is equal to, and one more part, 1 joule is equal to kilogram beta square per second square. Similarly, 1 erg is equal to, if it is kilogram, it will be in CJ system, gram centimeter square per second square. Similarly, like 1 joule, here 1 erg is equal to Newton of dyne per centimeter. Newton meter, dyne centimeter. Newton meter, dyne centimeter. Newton meter, not Newton meter square. Newton meter, dyne centimeter. Whereas if you are converting into kilograms, kilogram meter square per second square, erg gram centimeter square per second square. Some student is asking a difficult question. Yes, Dhanush, I am going to give you, no problem. I will give you. I will give you. Very good question I am going to give you. Before that, power. We are going to learn power. From using power, we are going to find the, what is that? Energy. Power to energy. We are going to do now. We know that power is equal to energy by time. What are the units of power? Units of power are watts. So energy is equal to power into time. So it is watt second. Watt second. Given power of a photoelectron or something I am giving you is some 4 watts and time interval is 4 seconds. Find work. Not difficult. Actually, it is normal question. I didn't even give you a difficult question at all. Just we have to use the formula. I gave you power, I gave you time. Just convert it. That's all. That's all. I didn't ask anything else. What is energy? Energy is equal to power into time. What is power I gave you? 4 watts. Time is how much? 14, 4 seconds. So answer is 16 watt second is the answer. How many of you got the answer? 16 watt second. Very good. Fatima, Naman, very good, very good. Right. Remaining students, those who are doing, complete it. One joule is equal to 1 watt second. Given energy of electron is something around 64 into 10 to the power of minus 16 joules. And time is 16 seconds. Find the power. We know that power is energy by time. Energy value is 64 into 10 to the power of minus 16 by time is 16. Complete it. A little more easy, definitely. Emmanuel, I will give you a very easy one, no problem. Next we will do Emmanuel. Previous slide. First do complete this, guys. I will open the previous slide. Okay. Okay, Emmanuel. Energy they gave you how much? 64 into 10 to the power of minus 16. Time is 16 seconds. 16 into 10 to the power of minus 16 is the answer. What is the units? Watt. Why? Here units are watt second. Here units are second. So watts. Watt second. 1 watt second is equal to 1 joule. I already gave you. Give very difficult. Cherry, fine, Cherry. But first Emmanuel also has to do no. We'll give one question for Emmanuel also. Then we'll give difficult question for you. Okay? Right then. Previous slide. Shall we move on now? Right then, we are going to next slide. Given the energy of an electron, it is difficult. Somebody asked me, no, Cherry, first we will do difficult now. Energy of electron or photon is 25.6 into 10 to the power of minus 19 joules. Bit 1 convert into electron volt. Bit 2 convert into arcs. Bit 3 find the power if the time period is or time is 16 seconds. Okay, Jerry, satisfied? Now, Emmanuel, you can also do with me. Let's start with the first one. Convert into electron volt, Emmanuel. How to convert this into electron volt? We know that 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. We learned this or not? Now, how much joules I gave you? 25.6. You keep it here. 25.6 into 10 to the power of minus 19 joules. This is x. X is equal to cross multiplication. 25.6 into 10 to the power of minus 19 by 1.6 into 10 to the power of minus 19. So what is the value? Anyone from the chat? Anyone can give the answer. I am checking now. If they are saying find the time, then it will be energy by power. Energy by power, mister. Okay. 256 by 25.6 by 16. It is how much? 16. 16s are 256. So what is the answer? It will be 16, I think so. 16 is the answer. How many of you got the answer 16? Sixteen, very good, very good. Zareen, very nice. Manikumar, Ananya Kumari, Fatima, very good. Very good. Nice, nice. Continue with the remaining part. Do it. Remaining part also. What about the B? Convert this into erg. We know that 1 erg is equal to 10 to the power of minus 7 joules. I gave you 25.6. 25.6 into 10 to the power of minus 19 joules. It is x. What is x value? X is equal to 25.6 into 10 to the power of minus 19 into 1 by 10 to the power of minus 7. Substitute. What is the answer? 10 to the power of minus 12 we will get here. So answer is, here answer will be how much? 25.6 into 10 to the power of minus 12 arcs. How many of you got the answer? Very good. Very nice. Very nice. Maniket Anand, Chandrahas. Very good, Chandrahas. Very nice. Good. So what about the big? What about the last part? I gave you time 16 seconds. Do it, guys. Now we know the energy. We have to find the power. How to find power? We know the power formula. Power is equal to energy by time. In joules, I gave you 25.6. I gave you into 10 to the power of minus 6 joules. By time, time is 16. So, what is the answer? 16. Complete it. This will become 10 to the power of minus 20. 16 into 10 to the power of minus 20 or 1.6 into 10 to the power of minus 19. What is the answer? How many of you got the answer? Very good. Very nice. Very nice. Chandras, Fatima. Very good. So you are getting the answers. Very good, guys. Very good. So for Emmanuel, we have to do a very easy question also. Emmanuel asked us. Emmanuel asked us. So let's continue. We'll do one easy question now. Ready? Given power is equal to some 64 watts. Time is equal to 1 second. Find the energy in electron volt. We are going to get the answer in joules. Convert that into electron volt. Electron volt. Complete it. First, power is equal to energy by time. We know that. So energy is equal to power into time. Power they gave you 64 watts into time 1 second. 64 watt second. That is equal to 64 joules. We know that 1 watt second is equal to 1 joule. Now convert this into electron volt. How to convert? 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. Okay. Now 64 joules we are having X. Emmanuel doing by 1.6 into 10 to the power of minus 19. So it will be 16 fours are 64. 4 into 10 to the power of plus 20 is the answer. How many of you got the answer? 4 into 10 to the power of 20. Very good. Electron volts. It is in electron volts. Nice. Very good. Very good. Very good. Nice. Nice. Nice, guys. Nice. Sir, technical person, they are asking something here. Okay, already informed. Okay. Right. Very good, guys. Very good. Very good. Nice. Nice, guys. So next we are going to learn about the mole concept. Yeah, Mr. Nilesh, doubts session. Yeah, tell me whatever doubts you're having. Yeah, please. Okay, they will take care of that. So tomorrow we will start mole concept part. Yes, Subhan Reddy. Doubts? See, one thing is whatever doubt, some students they are feeling like these concepts are there in the learn. These are the basic part we are learning right now. We are doing the conversions while all the right all the conversions. No, it's see already present everything clearly on the board. Everything I gave you clearly. Like we will have discussion easily once. Start with the joules. Like 1 joule to 1 erg. If you are doing calorie, 1 calorie is equal to how many joules? 1 calorie is equal to 4.184 joules. 1 calorie 4.184 joules. 1 erg is equal to how much? 10 to the power of minus 7 joules. Okay. Then 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. These are very important for us, which we are using 100% definitely. Temperature. For temperature, Kelvin is equal to degrees Celsius plus 273. Degrees Celsius is equal to Kelvin minus 273. Degree Fahrenheit is equal to 9 by 5 into degrees Celsius plus 32. Degree Celsius is equal to Fahrenheit minus 32 into 5 by 9. That's all. Okay, guys, that's all from my side. I have doubt. Please explain. Yeah, Mister. What is the doubt, Mister? What is the doubt, Mister? Yeah, Cherry. Thank you. Thank you. How to convert to joule? See, joule is actually we know. Joule already we learned about joule. Joule is a unit of energy or work. Okay. So we have to take one standard. Joule is SI unit. If you are converting into CGS unit or how what you are doing. Yeah, Emmanuel. Yes, yes, Mister. Okay then. Thank you, guys. Thank you.
So, what did we do in the last class? Last class we completed a topic. What topic did we complete? Yes, we completed a topic, no? Cell, the unit of life. So, actually, our CBC classes are running in a very beautiful way. Okay, so though first we learned about the human circulatory system, okay, that's a little Zara Hatke topic as it is given in our CBC material, but thereafter we learned about the cell, the unit of life, okay, and we learned about the structure, what is cell, who discovered cell, what is the structure of the cell, what are the types of cell, and everything we learned, right? We also know in our school level, we are also knowing a fact that the cells which are performing similar function are together forming a tissue. Cells which are performing similar function are called as a tissue, right? Okay. Now, what is exactly a tissue is our next zoology topic, that is animal tissues. Okay, so tissues is our next zoology topic. That is, we are going to learn about different types of tissues, how many types of tissues are present in the human body, what are the function of tissues, how do we classify the tissues, everything we will be learning in this week in the chapter animal tissues. So shall we get into the chapter? Yes, shall we get into the chapter? Okay, chalo. So, coming to the chapter animal tissues. Okay, so what exactly is a tissue? As I mentioned earlier, tissue is nothing but the cells which are performing a similar function are aggregating to form a tissue. Okay, chalo. Let me write that point over here. Cells performing cells performing similar function aggregate to form tissues. Point to be remembered, all the cells in the tissues will be having the similar function, cells which are performing similar function are aggregated to form tissues. Okay, next, study of cell is called as cytology. Study of cell is called as cytology. Cells are forming tissues, so study of tissues is called as histology. It is called as histology. Okay, or it is having another name, that is microanatomy, So cells which are performing similar function are aggregated to form a tissue. The study of cell is called as cytology, which we have already studied in the chapter Cell, the Unit of Life. But the study of tissues is called as histology or microanatomy. It is called as histology or microanatomy. Okay, so now coming to the next one, that is types of tissues. Okay, there are four types of tissues. How many types of tissues are there? There are four types of tissues. What are the four types of tissues? Number one, epithelial tissue. Number two, muscular tissue. Number three, nervous tissue. And number four, connective tissue. Okay, so in our body we are having four types of tissues. Okay, four types of tissues are epithelial tissue, connective tissue, muscular tissue and nervous tissue. The irony is that tissues are made of cells and cells are more minute than tissues. The study of tissues is called as microanatomy. Acha, here you are talking about the tissue level, you are comparing it with the cell. What I am saying is, what is anatomy? Anatomy is nothing but anatomy is a subject. Okay, anatomy is a subject. This subject is telling you about the study of all the internal organs. Okay, organs are made up of tissues, right? So tissues is microanatomy. Understood? You are comparing tissues with the primitive level, that is cells. I say that anatomy is study of organs. So comparing with organs, primitive level is tissues, which is microanatomy. Is it clear, Akshaya? Did you understand how it is named so? Got it? Yeah. So these are the four types of tissues, and we will be learning today about the epithelial tissues. Okay, we are going to learn about each one in detail, and the first one that we are going to learn is nothing but epithelial tissues. Okay, now epi means upon, thelia means growth. Epi means upon and thelia means growth. Okay, so the word epithelial tissue, we can divide it and we can say why is it called as epithelial tissue. Epi means upon, thelia means growth. So this is a type of tissue which is usually present upon the surface, Okay, now I'm going to write about few points regarding the epithelial tissue. Okay, point number one, it is having it, or you can say it is the first we'll start from this. It is the first tissue developed during embryogenesis. It is the first tissue developed during embryogenesis. When the embryo is developed, the first tissue that is developed is epithelial tissue. Next, it is originated from three germinal layers. Okay, the three germinal layers are, number one, the three germinal layers are ectoderm, mesoderm, and last one is endoderm. Okay, ectoderm, example we have epidermis, which is nothing but stratified epithelium. I'll tell you the justification of those names later. For now, remember the terms. That when an embryo is formed, okay, I'll tell you what is the germinal layer. First, what happens during reproduction? There is a sperm, male gamete, there is an ovum, female gamete. Both of them fuse to become a zygote. Now it has become a diploid cell, right? It has become a diploid cell. Now this zygote starts dividing. So when it is reaching a condition of 8 to 16 cell stage, it is called as morula. Then it is reaching greater than 16 or greater than 32 cell stage, which is called as blastula. Then the cells which are there present inside, the different cells, they start developing into layers: outer layer, middle layer, inner layer. When these three germinal layers are developed, the stage is called as gastrula. From each layer, different organs are developing. But when we are talking about the tissues, the first tissue that is developed during embryogenesis is epithelial tissue, and it is developed from all the three germinal layers. From the ectoderm, it is epidermis. From the mesoderm, it is mesothelium. And from the endoderm, it is called as endothelium. Okay, epidermis is stratified squamous. For now, just remember the names. Afterwards, you will understand what are these terms. Stratified squamous. Mesothelium is simple squamous. Okay, endothelium is also simple squamous. Okay, got it? So it is originated from the three germinal layers. It is originated from the three germinal layers. Okay, next point, it has highest regeneration capacity. It has highest regeneration capacity. It is having highest regeneration capacity. Just imagine if you see that you are having a cut over your skin. Okay, after some time it will be getting cured. It will be forming a new layer of cells, epithelial cells, right? So even if there is a cell damage, rupture in the tissue, then it is able to show certain wound covering. It is able to show certain wound covering. It is able to like sort of cure itself. It is able to repair itself. That is the reason why we say that it is having the highest regeneration capacity. So if you are asked that which tissue is having the highest regeneration capacity, it is the epithelial tissue. It is the epithelial tissue. Okay, the least regeneration capacity is shown by the nervous tissue. The least regeneration capacity is shown by the nervous tissue. If there is any damage to your nerve cell, then what will happen? The regeneration capacity, because it is very low, that is why neural control is damaged. The nervous system is damaged. Understood? But when there is any damage to the internal organ, let it be internal cells or the epithelial, the outermost layer, that is skin, whenever there is a damage in these layers, it can be repaired because epithelial tissue has highest regeneration capacity. It is having highest regeneration capacity. Now, it has cells compactly packed, compactly packed with very less intercellular matrix, intercellular matrix. Okay, the cells are arranged so close to each other that there is no internal space between them. There is no intercellular space. That's what this means. The cells are compactly packed with each other such that they are having very less intercellular matrix. And cells have free surface, free surface, which is either facing body cavity, which is either facing body cavity or external environment, or external environment. Okay, so what do I mean is that first thing, how are the cells arranged? The cells are compactly packed so that they are having very less intercellular matrix. Okay, how are the cells? The cells are having free surface. Nothing is present over the surface. They are having a free surface which is either facing the body cavity or it is facing the external environment, or it is facing the external environment. Okay, I will write about these germinal layers which I mentioned. Zygote. Okay, how is a zygote? Like this. Okay, zygote turns into morula. What is morula? Morula is having 8 to 16 cell stage. Morula is having 8 to 16 celled. Okay, next, this morula is further divided into blastula. It is further divided into blastula. Blastula is having even more number of cells. That is approximately it is having greater than 32 cell stage. Greater than 32 celled stage. Then after blastula, last one is gastrula. Okay, what is gastrula? Gastrula may you will be seeing the formation of the germinal layers. Okay, all the cells internally, they are being divided into three layers. They are being divided into three layers. What are the three layers? The three germinal layers are developed. The three germinal layers are developed. This is what is embryonic development. This is what is embryonic development. And is it clear? Okay, that is how the embryonic development takes place. So I have explained you this, that how, what are the three layers, what are the three layers. Okay, so what do we know? First tissue that is developed during embryogenesis, first tissue that is developed during the embryogenesis, it is made up of three germinal layers. It has highest regeneration capacity. The cells are compactly arranged such that there is very less intercellular matrix. Cells are having free surface which is either facing the body cavity or it is facing the external environment. Now I will show you how exactly it looks like. Okay, these are the cells. Let's say these are the epithelial cells. This is the nucleus. Okay, epithelial cells are present. Epithelial cells are present on a basement membrane. Epithelial cells are present on a basement membrane. Okay, basement membrane, there is a base. Okay, what is this base? This base is called as the basement membrane. Epithelial cells, epithelial cells, free surface. Okay, this is what is called as the basement membrane. Point to be remembered that basement membrane is having two layers. What are the two layers? One is basal lamina, and the other one is reticular lamina. The two layers are basal lamina and reticular lamina. Okay, these two together are forming a basement membrane. What is basal lamina? What is basal lamina? It is made up of mucopolysaccharides, mucopolysaccharides and glycoproteins, glycoproteins produced by epithelial cells. Okay, these epithelial cells are producing certain mucopolysaccharides and glycoproteins. Mucopolysaccharides and glycoproteins, which are forming the basal lamina. Coming to reticular lamina, it is made up of collagen, collagen and reticular fibers, reticular fibers made by or produced by connective tissue, produced by connective tissue. Okay, so this one is made up of collagen and reticular fibers. What I want to show you over here is that these are the epithelial cells. Here we are having the nothing but the connective tissue. We are having the connective tissue. This is connective tissue. Basal lamina and reticular lamina together make up the basement. Together make up the basement membrane. Together make up the basement membrane. Basement membrane, what does it do? It is a non-living acellular layer. Acellular layer. Got it? Okay, so if you see here, these are the epithelial tissues or epithelial cells which are lined or which are present on the basement membrane. This basement membrane is having two layers, basal lamina and reticular lamina. Basal lamina is made up of mucopolysaccharides and glycoproteins produced by the epithelial cells, whereas reticular lamina is made up of collagen fibers and reticular fibers which are made up of the connective tissue, which are produced by the connective tissue. Now, for a point that is supposed to be remembered, that how are the cells arranged in epithelial tissue? The cells are arranged very compactly, which are having very less intercellular matrix. So, because of less intercellular matrix, less intercellular matrix, epithelial tissue is avascular. It is avascular, which means not provided with blood vessels, not provided with blood vessels. Then how does it get its nutrition? It extracts nutrition. It extracts nutrition by extracts nutrition from is better, connective tissue. Okay, this is a very important point, that epithelial tissues, they are not having any sort of blood vessels provided to them. Rather, they get its nutrition from the surrounding connective tissue. They get its nutrition from the surrounding connective tissue. Okay, so the nutrients from the connective tissue, they are being absorbed and taken by the epithelial cells. They are being absorbed and taken by the epithelial cells. Okay, so from connective tissue, nutrients will be absorbed. Nucleus. This is how the structure of epithelial tissue looks like. Okay, this was about the basic structure of epithelial tissue. But there are different types of epithelial tissue. Okay, I want you people to remember this in a flowchart form so that you people don't get confused. Okay, moving on to the next one, that is types of epithelial tissue. Got it? Now when I talk about the types of epithelial tissue, the very first one, when I make it like this, it becomes much easier. Okay, types of epithelial tissues. What do, if I write it over here, what do I mean? Based on what? Okay, on the basis of, on the basis of number of cell layers, on the basis of number of cell layers. Okay, I can classify them into simple epithelium, simple epithelium, and compound epithelium, and compound epithelium. Okay, there are two types of epithelium, simple epithelium and compound epithelium, which is on the basis of number of cell layers. Okay, simple epithelium have one single layer of cells, one single layer of cells, whereas compound epithelium have multiple layer of cells, multiple layers of cell. Okay, coming to its function, simple epithelium, they are having a function like help in diffusion, absorption, secretion, like functions, whereas compound epithelium help in compound epithelium help in protection from mechanical stress, protection from mechanical stress. Okay, so their major function is protection, their major function is protection. So on the basis of number of cell layers, they can be classified into simple epithelium and compound epithelium. Simple epithelium, I will just draw it like one diagram so that it's easy for you to understand. It is having only one layer of cells, whereas compound epithelium is having multiple layer of cells, whereas compound epithelium is having multiple layers of cells. Got it? Okay, so this is on the basis of cell layers. Now, this simple epithelium can be further classified on the basis of, they can be further classified on the basis of cell shape, on the basis of cell shape. Okay, what are the different types? First one is simple squamous, simple squamous. Second one is simple cuboidal, simple cuboidal. Last one is simple columnar, simple columnar. Okay, so these are the three types of simple epithelium. Now let me show you how exactly simple squamous looks like. First we'll draw the diagram, then we will learn about the function, then where it is present. Okay, location, function, the diagram. Coming to simple squamous, simple squamous has one layer of single layer of flat irregular shaped cells. Flat irregular shaped cells are there. Okay, second point we write about location. Now when I write L, I mean location. When I write L, I mean location. Simple squamous are present in endothelium of blood vessels, endothelium of blood vessels, and alveolar sacs. Last point what I write is F. F means function. Okay, function is it is useful for diffusion of substances. It is useful for diffusion of substances. Okay, so simple squamous epithelium is having single layer of flat irregular shaped cells, due to which it is having a tile like appearance. It is having a tile like appearance. So it is called as the pavement membrane. It is called as the pavement membrane. Okay, tile like appearance, so it is called as the pavement membrane. Moving to next one, that is simple cuboidal. First we draw the diagram. It is having single layer of cube like cells, cube like cells with central nucleus, with central nucleus. The nucleus is present at the center. Second one, I write about the location. PCT of nephron and ducts of exocrine glands exocrine glands. They are all having simple cuboidal epithelium. Then I write about the function. Function is absorption and secretion. Function is absorption and secretion. Simple cuboidal epithelium. Last but not the least is the simple columnar epithelium. It is having tall slender cells with nuclei present at its base. Tall slender cells with nuclei present at base. Okay, then we write about the location. It is present in inner lining of stomach and intestine. Inner lining of stomach and intestine. Last but not the least, the function is again absorption and secretion. Again, it is responsible for absorption and secretion. Okay, in simple terms, you are supposed to remember depth. Okay, uh, yes, depth. In depth, you will be learning in the chapter structural organization. First, I'm just introducing you the terms. Understood? Simple squamous epithelium because it is having single layer of flat, irregular boundaried cells. They are irregular shaped cells. It is appearing like a because they are flat, no, one layer only. It appears like a tile. Okay, it is having a tile-like appearance. Okay, that is the reason why it is called as a pavement membrane. It is called as a pavement membrane. I hope this is clear. Simple cuboidal cube-like cells present in PCT of nephron and ducts of exocrine gland. Function, absorption and secretion. Simple columnar, name itself is telling tall, slender cells, but nuclei is present at the base of the epithelial cells. It is present in the inner lining of your stomach and intestine. Again, the function is absorption and secretion. So if you see simple cuboidal, simple columnar, both of them functions are absorption and secretion. Whereas if you see the functions of simple squamous, it is diffusion. It is diffusion. See, here it is given already. Okay, now there are certain modifications which are made in the cuboidal and columnar cells. There are, I am still in simple epithelium. I'm telling you people again, I am still talking about simple epithelium only. We have not yet moved to compound epithelium. Okay, next, if you see tie or modifications in cuboidal, in simple cuboidal and columnar and simple columnar epithelium. Okay, they are having certain modifications. They are having certain modification. So based on the modification, they can be further classified into two types. On the basis of modification, on the basis of modification, they can be further classified into two types. What are the two types? Number one is glandular epithelium. Number one is glandular epithelium. And number two is ciliated epithelium. Number two is ciliated epithelium. Now, what are these modifications? What are these modifications? If cuboidal or columnar or columnar cells are modified are modified to produce certain secretions, they are called as glandular epithelium. Next, if cuboidal and columnar cells develop short hair like cilia, it is called as ciliated epithelium. It is called as ciliated epithelium. Okay, so glandular epithelium is different and that is ciliated cuboidal. It depends, Nana. It depends. I am particularly talking about on the basis of modification. There could be certain this which are having the modification of producing certain secretions. Understood? Okay, if they are producing secretions, they are called as glandular. If they are having on the free surface, I will draw the diagram over here. On the free surface, if it is having certain small hair-like structures called as cilia, then it is called as ciliated epithelium. Now, this glandular epithelium can be further classified on the basis of two categories. On the basis of number of cells, on the basis of number of cells, on the basis of ducts, on the basis of ducts. Okay, so on the basis of number of cells, it can be classified again into two categories. On the basis of ducts, it can be again classified into two categories. Okay, what are they? On the basis of number of cells, unicellular glandular epithelium and multicellular glandular epithelium. On the basis of present or absence of ducts, it can be given as endocrine and it can also be given as exocrine. Exocrine glands and endocrine glands. Okay, now what is unicellular glandular epithelium? Unicellular glandular epithelium, name itself is telling only one cell. Example is mucocytes of small intestine, okay, which are producing mucus. Multicellular glandular epithelium, cluster of cells which is having cluster of cells. Example, salivary glands. Example, salivary glands. Endocrine glands are ductless glands. They are ductless glands. Endocrine glands produce hormones. Exocrine glands are duct glands. Duet kadana idi duct. Yeah, duct glands. What do these exocrine glands produce? They produce oil, sebum, sweat, etc. Okay, this is how on the basis of ducts and on the basis of number of cells they can be classified into two categories. They can be classified into two categories. This is not yet completed, Nana. You are telling me to move. Next one, again, exocrine gland, again on the basis of mode of pouring secretion. On the basis of mode of pouring secretion. Mode of secretion. It can be further classified into three categories. What are the three? How are they producing secretion? First one is merocrine gland. Next one is apocrine gland. Last one is holocrine gland. Holocrine gland. Okay. Now, what are these? Merocrine glands. See, they are duct glands. They are duct gland. Now, for example, when a cell is or when a tissue is producing certain secretion, if no part of the cell is getting disintegrated, if no part of the cell is getting disintegrated along with the secretion, this is the cell. Okay, this cell is producing certain secretions, but there is no cellular loss. In that case, it is called as a merocrine gland. Example for merocrine gland is pancreas. Example for merocrine gland is pancreas. Next one, apocrine gland. If this is the cell and you see the apical part of the cell is getting disintegrated along with the secretion. It is getting the apical part. Apical means the tip is getting disintegrated along with the secretion. It is called as apocrine gland. Example, mammary glands. Example, mammary glands. If holocrine, if the whole cell is getting disintegrated along with the secretion, then whole na, whole matlab entire cell is getting disintegrated along with the secretion. It is called as holocrine gland. Example, oil glands of skin. Example, oil glands of skin. Okay, this was about only glandular epithelium. This was about only glandular epithelium. Okay, next moving to ciliated epithelium. Next moving to ciliated epithelium. Ciliated epithelium means they are having cells present on the basement membrane. They are having cells present on the basement membrane. On the surface, they are having short hair-like structures called as cilia. They are having short hair-like structures called as cilia. Okay, where is cilia present? Cilia helps in movement of mucus and particles. Okay, location inner lining of bronchioles for movement of air particles, for movement of air, and inner lining of fallopian tube, inner lining of fallopian tube for the movement of ova, for the movement of ova. Got it? Okay, very simple. Cilia, it is having, the cilia is ciliated epithelium. The cells on the free surface are having short hair-like structures called as cilia, which are helpful for the purpose of movement of particles, which are helpful for the purpose of movement of particles. Okay, and where are they present? They are present in the inner lining of the bronchioles, inner lining of the windpipe, which will help in the movement of air, and it is also present in the fallopian tube. When we talk about the male and the female gamete, in case of human beings, sperm is motile. It is having a tail, it can flow. But when we talk about ova or egg, it is non-motile. It is non-motile. When it is non-motile, how is the egg transferred from the ovary to the fallopian tube, and how will it reach the uterus? Because the fallopian tube is internally lined by the small hair-like structure containing epithelia, that is ciliated epithelium, which will move synchronously or simultaneously, pushing the ova forward, Okay, this is about the location and function. Most important difference between microvilli and cilia. Okay, difference between microvilli and cilia. So microvilli is finger-like, whereas cilia is hair-like. Okay, microvilli increase the surface area for absorption. Increase the surface area for absorption. Whereas cilia help in movement of particles and mucus. That's it. Only two differences. Okay, it helps in the movement of particles and mucus. Is it clear? Yes, is it clear? I will once repeat the entire class. Coming to the topic animal tissues, the cells which are performing similar function are aggregated to form tissues. The study of cell is called as cytology, whereas the study of tissues is called as histology or microanatomy. There are four types of tissues which are present in the human body. What are the epithelial tissue, connective tissue, muscular tissue, and nervous tissue? Coming to the first one, that is epithelial tissue. Epi means upon, thelia means growth. The first tissue that is developed during the embryonic development is called as epithelial tissue. It is originated from the three germinal layers. They are ectoderm, mesoderm, and endoderm. Ectoderm, mesoderm, and endoderm. It is having the highest regeneration capacity. The cells are so compactly arranged with each other that there is very less intracellular matrix, and because there is very less intracellular matrix, they are not provided with blood vessels, rather they are absorbing the nutrients from the connective tissue. They are having a free surface which is either facing the body cavity or it is facing the external environment. Sorry. This is how the structure of epithelial tissue looks like. So you can see the epithelial cells are resting over a acellular non-living layer which is called as the basement membrane. The basement membrane has two layers, basal lamina, reticular lamina. Basal lamina is made up of mucopolysaccharides and glycoproteins which are produced by the epithelial cells, whereas reticular lamina is made up of collagen fibers and reticular fibers which are produced by the connective tissue itself. So, as I told you earlier, that because of very less intracellular matrix, it does not have blood vessels. It is avascular. Then, how does it get its nutrients? The diffusion of the nutrients from the connective tissue to the epithelial cells occur. Okay, next, types of epithelial tissue. First category on the basis of which it is classified is on the basis of cell layers. One layer of cell, simple epithelium. Multiple layers of cell, compound epithelium. One layer of cell will allow the transportation of substances. So it will be helpful for diffusion, absorption, excretion, etc. Secretion, etc. But compound epithelium, because multiple layer of cell, can it allow the transportation? Compound epithelium is limited in absorption and secretion. Rather, it is useful for another function, that is nothing but protection from the mechanical stress. Protection from the mechanical stress. Next, on the basis of cell shape, the simple epithelium can be classified into three categories. If the cells are irregular shaped flat cells, simple squamous. Irregular shaped flat cells are helpful for the diffusion process. They are present in the endothelium of the blood vessels and the air sacs, that is the alveoli of the lungs. Next one is simple cuboidal. If the cells are cube-like cells arranged on the basement membrane, which are having a central nucleus responsible for absorption and secretion. Where are they present? In the ducts of the exocrine glands and proximal convoluted tubule of nephron. I hope you know the structure of nephron. So, proximal convoluted tubule of nephron is having simple cuboidal epithelium. Next one, simple columnar, column-like tall slender cells with the nuclei which is present at its base is called as simple columnar epithelium. They are present in the inner lining wherever absorption and secretion. Stomach and intestine are internally lined by simple columnar epithelium, which are helpful for absorption and secretion. Now, this cuboidal and columnar are having certain modifications. Based on this modification, they can be classified into glandular epithelium and ciliated epithelium. Glandular epithelium produces certain secretions, whereas ciliated epithelium helps in the movement of the particles. Simple. Okay. Glandular epithelium on the basis of number of cells. One cell, unicellular glandular epithelium, where it is present in the mucocytes of the intestine. Mucocytes are the specialized cells which are present in the small intestine, which help in the production of mucus. That is the reason why they are named as mucocytes. Next one, multicellular, cluster of glandular epithelial cells which help in production of certain secretion. They are present in the salivary glands which produce saliva. On the basis of ducts, okay, how are they able to transport their secretion? On the basis of ducts, they can be classified into endocrine and exocrine. Endocrine, no ducts are present. The productions of endocrine glands are called as hormones. Example, pituitary gland, thyroid gland, adrenal gland, ovaries, testes, all these come under endocrine glands. Next one is exocrine glands, which are having ducts. What is it producing? It is producing oil, sebum, saliva, sweat, etc. They are having ducts for the transportation of those secretions. Those are called as the exocrine glands. Example of exocrine glands could be salivary glands. These exocrine glands, on the basis of how are they producing the secretion, they can be classified into merocrine, apocrine, and holocrine. Merocrine, no cell is disintegrated along with the secretion. Example, pancreas. Apocrine, only the tip is pinched off along with the secretion. Mammary gland. Holocrine, oil glands of the skin which are helpful for production of the secretion by elimination of the entire cell along with the secretion. That is what is called as the holocrine gland. Last one is ciliated epithelium. The cells are having cilia, hair-like structures present on the surface which move simultaneously for the movement of the particles. It is present in the inner lining of bronchioles or bronchi, that is windpipe, for the movement of air, and it is helpful for the movement of ova in the fallopian tube. There is a difference between microvilli and cilia. Microvilli is finger-like projection, whereas cilia is hair-like structure. Microvilli is increasing the surface area of absorption and secretion in the small intestine, whereas cilia is helpful for the movement of the particles. This is about the simple epithelium. So tomorrow we will be learning about the compound epithelium, and the cells of epithelial tissues, they are compactly arranged by certain types of junctions. So we'll be learning about the cellular junctions and the compound epithelium. Then we will be moving into the next type of tissue, that is connective tissue. Is the class clear? Yes, is the class clear? Yes or no? Yes, epithelial tissues is in the flow chart form. Is it easier to understand? Yes, okay. So tomorrow, as I told, we'll be learning about the cellular junctions, then we'll be learning about the compound epithelium, okay? And then we will be moving into the next type of tissue. That's it for today's class. Take the notes, wait for the PDF to come, take the notes, understand it, try to understand, try to read it, understand it, take it from the CBC material as well, and then you will be familiar with the terminologies. All new terminologies at once, obviously, it will be a little difficult. I want you people to learn it yourself. If you read it once, it will be easier for you people to understand. Okay. So since lack of time, we'll be knowing about the facts in tomorrow's class. Okay. Thank you, students. That's it for the day. Wait for the PDF to come. Don't go without the PDF. Then you people will be asking, ma'am, yesterday's notes, today's notes. No, take the PDF, download it, and then go. Thank you, students. That's it for the day. Have a great day.